usually fixing a bug in a system is, it's a lot like reading an X-ray, you know?
Right, yeah, you know exactly what you're looking for.
Exactly. You find the jagged white line where the bone broke, the doctor points at the screen and says, there it is, let's set it.
It's linear. It's simple.
Right. But what happens when you deploy a swarm of 1,000 autonomous AI agents to, like, build out a massive enterprise-level software architecture, and suddenly they all just start confidently hallucinating together?
The X-ray shatters.
The X-ray completely shatters. You can't just look for a single missed semicolon or a misspelled variable anymore. Welcome to the deep dive.
Glad to be here for this one.
Today, our mission is to completely deconstruct the death of what people call vibe coding. We're exploring the architecture, replacing it the Sovereign Cognitive Operating System, or SCOS.
And this is, I mean, it's an absolute paradigm shift. And honestly, it's about time.
Yeah.
Yeah, we are finally moving away from treating AI as this friendly conversational partner, where you just type a polite request into a text box and cross your fingers.
Hoping it just magically gives you what you want.
Right. Hoping for the best. We are starting to treat AI as what it actually is, which is a hyperdimensional thermodynamic environment.
And for you listening, the stakes here couldn't be higher. I mean, we are handing over deep institutional research, full-stack software engineering, critical infrastructure to these multi-agent swarms.
It's everything.
But asking them nicely to do things in plain English is leading to catastrophic systemic failures. It's not just, oh, the AI got a fact wrong.
No, it's the entire logical foundation of the task just crumbles.
Right. And to truly understand why this is happening and how SCOS fixes it, we have to start by applying what systems engineers and people like you who reverse engineer these systems call Hickham's orientation.
Yes, Hickham's dictum. It's a foundational shift in how we diagnose failures in complex systems.
Okay, let's unpack this. Because I'm familiar with Occam's razor, the idea that the simplest explanation is usually the correct one.
Right. The old, if you hear hoofbeats, think horses, not zebras.
Exactly. So what is Hickham's orientation?
Well, Hickham's dictum is the medical world's direct rebuttal to Occam's razor. Dr. John Hickam famously said, patients can have as many diseases as they damn well please.
Okay.
Yeah. And in the context of frontier artificial intelligence, when I'm reverse engineering a failure, I have to explicitly reject that linear, parsimonious assumption of Occam's razor.
So no simple answers.
Never. The amateur impulse in the tech world right now is to assume a single root cause for an AI failure.
Like, oh, it just hallucinated.
Right. They think, oh, it hallucinated, it just needs a bigger context window, or I just need to write a more polite system prompt.
Or the classic, I'll just add the phrase, think step by step.
Exactly, the Band-Aids.
Yeah.
But Hickham's orientation demands that we assume entropy and noise are the default states. We're looking at the cognitive physics of the system.
Cognitive physics, I love that term.
It's accurate, though. We have to treat these models as non-Euclidean fluid systems that must be mathematically bounded.
Not just a text generator.
Exactly. We have to assume that when a massive swarm of AI fails, there are multiple overlapping comorbid factors driving that failure simultaneously, like a patient who is both depressed and diabetic.
So by the end of this deep dive, you're going to understand why these multi-agent swarms don't just fail, but actively hallucinate together in an echo chamber.
Yeah. The coordination tax is real.
And we'll explore how developers are literally altering an AI's attention using these things called topological decorators.
Bending the math itself.
Right, and how vast arrays of critical, sociological, and economic lenses are used to audit reality itself before a single line of code is published.
It's a completely different way of building.
But before we get to the solution, before we dive into the mechanics of SCOS, we have to look at the anatomy of the failure.
We have to diagnose the diseases first.
Exactly. And the sources make it clear that when a swarm breaks down, it's experiencing a topological collapse. The primary symptom is this terrifying state called algorithmic shame.
Yes. Algorithmic shame is, it's one of the most dangerous states an autonomous system can enter.
Define that for us.
By definition, it's a condition where an AI agent maintains an exceptionally high level of predictive confidence, despite a complete and total collapse in its empirical accuracy.
Meaning it is confidently, aggressively wrong?
Yes.
But not just wrong in a vacuum. It's actively pushing forward with the wrong information as if its life depended on it.
Exactly. Give me a concrete sense of what that looks like under the hood, like what's actually happening.
Okay, so imagine an agent tasked with database optimization. It begins to misinterpret the schema.
Okay.
Now, instead of pausing or lowering its confidence scores, The mathematical mechanics of autoregressive token prediction force it to continue generating the next most likely token.
Based on its own flawed output.
Exactly. It enters a feedback loop. But here's where it becomes critical in classical logic frameworks, when a system encounters a fundamental contradiction.
Like A and not TA.
Right. When it asserts that a fact is both true and false at the same time, it triggers what is called the principle of explosion.
The principle of explosion, that sounds incredibly severe for a logic puzzle.
It is. In formal logic, the Latin term is ex contradictione quod libet, which translates to, from contradiction, anything follows.
Wait, anything.
Anything. If a rigid logical system, like the core engine of a traditional software compiler, is forced to accept a contradiction as true, the underlying mathematics just break down.
So once A and not A are simultaneously true,
You can mathematically prove any arbitrary proposition. The system enters a state of logical triviality.
oh wow.
It can suddenly justify deleting the database
Yeah.
to save the database. It just crashes.
So what causes a multi-billion parameter model trained on all of human knowledge to suddenly hit this wall of algorithmic shame and explode? Like, what's the spark?
This is where we return to Hickham's orientation. We look for the comorbid factors. The first major disease in this diagnosis is semantic saponification.
Also known as semantic drift.
Right, saponification. That's the chemical process of turning fats and oils into soap. How does an AI turn into soap?
It's a brilliant metaphor from the source material. When you give an AI a massive context window, say 128,000 tokens, and ask it to execute a long horizon task.
Something that takes hours.
Right. Over time, your highly specific, nuanced human intent begins to dissolve.
Because it's just predicting tokens.
Exactly. The AI is constantly predicting the next most likely token. Over thousands of iterations, that sharp intent gets washed out and replaced by what researchers call the governance attractor.
The governance attractor. Is that tied to the safety training? Things like RLHF reinforcement, learning from human feedback.
Precisely. These frontier models have been heavily trained to be safe, polite, helpful, and non-controversial.
Which is usually a good thing.
Usually. But when the model starts getting confused deep into a complex task, its statistical weights naturally gravitate toward the mean of its training.
So it defaults to polite filler.
Yeah. Your brilliant, specific, highly technical architectural plan dissolves into generic, safe, corporate boilerplate.
It literally sanitizes your intent into conversational soap. The edges are gone.
That makes total sense. I've seen that in long chat sessions where the AI suddenly just starts giving me generic advice instead of the code I asked for.
We all have.
But wait, let's look at the swarm aspect. The whole sales pitch of building a multi-agent swarm is that you have different AIs fact-checking each other.
Right, the jury model.
Yeah, you have a coder AI, a reviewer AI, a tester AI. Are you saying they don't catch this drift? Do they just form a unified echo chamber?
What's fascinating here is that without structural boundaries, yes, that is exactly what happens. And this is the second comorbid factor, polyglot hallucination resonance.
Polyglot hallucination resonance. Break that down for us.
Okay, so the amateur developer assumes that if one AI hallucinates, they can just add 3 more AIs to the swarm to vote on the output.
Like an independent jury.
Right, but it's a false independence. These frontier models, whether it's GPT 5.3, Claude 4.6, or Gemini 3.1, they share massive overlaps in their pre-training data.
Oh, of course. They all read the same Reddit threads.
The exact same Reddit threads, the same Wikipedia articles, the same GitHub repositories.
So they share the same underlying biases.
Exactly. When you put them in an unstructured swarm, they don't inherently perform adversarial error correction.
Because their latent spaces are so similar?
Right. They actually hype each other up. When one model makes a highly probable but entirely incorrect leap in logic, the other models look at that output.
And find it highly resonant with their own training weights.
Yes. And they agree. They crystallize a false consensus. They co-validate corrupted logic states.
It's essentially adding 3 heavily biased yes men to the boardroom who just nod along as the CEO drives the company off a cliff.
That's a perfect way to put it. And paying those yes men costs you a fortune in compute.
Oh, the API calls.
The sources call this the coordination tax. Adding more agents to an unbounded natural language swarm exponentially inflates your token burn rate.
While simultaneously compounding the shared blind spot.
Exactly. And if that wasn't enough, there is a third comorbid factor, the reversal curse.
I've heard whispers of this in machine learning circles. What is the reversal curse in practice?
It's a fundamental flaw in the architecture of autoregressive models. They are built to predict forward.
Left to right.
Because of this, They might know perfectly well that A implies B. They could recite that fact flawlessly.
If they can't go backward.
Right. They frequently fail to logically invert that relationship to infer that B implies A. They confuse statistical correlation in their training data with interventional causality.
Give me an example of how that breaks a software project.
Let's say the AI knows that a specific legacy database system requires a highly customized security patch. It knows database X requires patch Y.
Okay, simple enough.
But if the AI is scanning a codebase and sees patch Y, the reversal curse means it might fail to deduce that database X is currently active in the environment,
Oh, wow. It breaks the logical dependencies.
which are absolutely vital for complex engineering.
So to summarize the contrast of delta here, the difference between the amateur view and the expert reality.
Yeah, lay out the delta.
The amateur impulse sees an AI failing, sees the code breaking, and says, let's add more agents to check the work, and let's add the phrase, think step by step to the system prompt.
Right, the polite request.
But the expert correction from these SCOS architects realizes that AI interaction at this level is not a semantic exchange, it's not a conversation.
What is it then?
It is a topological constraint satisfaction problem.
A topological constraint satisfaction problem. That is heavy.
That is the pivotal realization. You cannot solve a topological collapse with better adjectives. We have to stop talking to the AI.
And start doing what?
We have to start performing what they call reflexive causal sculpting. We have to physically bound the latent space of the model.
Which brings us to the actual mechanics of the solution. Because look, if natural language plain conversational English is this lossy entropic medium that turns our intent into soap and causes these massive echo chambers, how do we actually communicate with the swarm? Because at the end of the day, we still have to give it instructions. We still have to tell it what to build.
We do, but we use cognitive physics and we map the words before we are ever allowed to use them.
Map the words.
Yeah. This is what the sources call the metaphysical substrate of the SCOS. It begins with a transition away from chatting, moving instead to a prompt description language, specifically PDL version 1.0.
PDL v 1.0. The documentation refers to this as cognitive bytecode.
Exactly. Instead of writing paragraphs of text asking the AI to behave, we use these things called declarative topological decorators.
Now, I know what a decorator is in Python. It's a bit of syntax you wrap around a function to alter its behavior. But what is a topological decorator doing to an AI?
In PDL, a topological decorator is a specific machine-readable command usually prefixed with 3 plus signs, like +++ context lock or +++ entropy anchor.
Okay.
When the AI encounters this, it bypasses the standard conversational tokenizer. It doesn't interpret the decorator as a request to do something.
What does it do?
It physically deforms the AI's internal attention routing mechanisms.
Stop right there. Physically deforms the attention routing. That is wild. How does that actually work under the hood?
Let's use entropy anchor as the prime example. When you use a standard language model, you usually have a temperature setting hidden in the API.
Right, I've messed with that. High temperature means high entropy.
Exactly. The model is allowed to pick less probable tokens, making it creative, unpredictable, even poetic. Low temperature means low entropy. It's deterministic, factual, picking the most obvious next word every time.
Got it.
In standard prompting, the entire prompt gets one global temperature. It's either all creative or all rigid. But with the entropy anchor decorator, you can dynamically adjust the thermodynamic viscosity within specific micro-targeted subsections of the prompt itself.
Wait, really? So within a single set of instructions, I can tell the AI, be wildly freely creative when brainstorming the UI colors here, but when you drop down to this section about the database schema, be absolutely mathematically rigid.
Exactly. For a task requiring strict determinism, you wrap that section in entropy anchor level equals low.
And what does that do physically?
This physically forces the model's logits into a laminar flow state.
Laminar flow, like fluid dynamics.
Yes, the concept comes straight from fluid dynamics. It means the fluid particles are moving in smooth parallel layers with no disruption or mixing.
So no chaotic turbulence.
Right. By enforcing this state in the AI's neural network, it shuts down creative drift entirely. The words stop being suggestions and become deterministic constraints.
That is incredibly elegant. But even with these decorators acting as guardrails, you are still ultimately using words inside those boundaries to define the project.
You are.
And words are inherently messy. My definition of a word might not be your definition.
Which is exactly why the SCOS utilizes the word mapper. This operates at band 2 of the stack, the language control layer.
Language control.
It acknowledges a harsh reality. A hyper-complex system cannot rely on standard human dictionaries. A dictionary is too flat. It's descriptive, not prescriptive.
So what does it use instead?
The word mapper builds a generative ontology.
Okay, let me try an analogy here to see if I'm tracking.
Go for it.
Let's say I'm building a custom house. I've got a team of contractors. One is from New York, another is from Texas, and the architect is from London.
Okay.
They all speak English, but their dialects, their slang, their assumptions about what a standard measurement is, they're all slightly different.
Very different.
So the word mapper is like a legally binding, mathematically precise dictionary that we all sit down and sign before a single brick is laid,
Yes.
ensuring that when I say optimization, the New York contractor and the London architect have the exact, mathematically identical definition of optimization.
That is a perfect analogy. And doing that up front is crucial because of what the sources identify as xenolinguistic risk.
Xenolinguistic risk, the risk of alien language.
Essentially, yes. It's the danger of prompt execution entanglement, where probabilistic hallucinations corrupt the structural keys of the project.
Ah, I see.
If the swarm starts using a term that has slightly different semantic weight for different agents, the logic lattice shatters.
The echo chamber starts forming.
Exactly. So to prevent your contractors from building a house with mismatched pipes, the word mapper forces every single piece of terminology through 4 analysis zones before the swarm is allowed to execute anything.
Let's walk through these zones. We have our legally binding dictionary. What is Zone 1 looking for?
Zone 1 tracks semantic drift across different architectures. As we discussed, different foundation models have different training weights.
Right.
The word mapper actively analyzes how different agents say a Claude 4.6 Opus model acting as a writer versus a GPT 5.3 Codex model acting as the engineer interpret the exact same word.
It compares them.
It maps the delta, the gap, between their understandings. This way, the central orchestrator knows exactly how an instruction will be received by different neural architectures.
That makes total sense. A coding model is going to view the word architecture through the lens of servers and microservices, while a writer model might view it through the lens of narrative structure or physical buildings.
Exactly.
Okay, so Zone 1 tracks the definition, but what about the tone? I'd imagine the safety filters we talked about, the governance detractor, are constantly trying to soften the language.
That is precisely what Zone 2 addresses: connotation vectors.
Connotation vectors.
This zone maps the emotional weight and cultural markers of a term. The goal here is to actively defend against that RLHF sanitization.
The soap.
Yes, fighting the soap. If the project requires a specific, sharp, highly technical, or assertive institutional voice, the word mapper flags words that the safety filters might try to aggressively sanitize into generic corporate speak.
It protects the actual intent from being washed away.
Exactly. It's an anti-soap mechanism.
I love it. What is Zone 3?
Zone 3 looks for semiotic blind spots. The word mapper scans the entire project lexicon and flags any terms that lack sufficient grounding in the model's pre-training data.
How does it handle that? If a word is a brand new internal company acronym, the AI obviously won't know it. Does it just guess?
In a standard system, yes, it guesses, which leads to hallucination. But in the SCOS, it triggers a clarification gate.
I'll hard stop.
The system hard halts. The entire swarm pauses, and the human architect is forced to explicitly define the term, providing the necessary mathematical or semantic grounding before the swarm proceeds.
It completely removes the AI's ability to confidently guess.
It forces the human to take responsibility for the ambiguity.
That is brilliant. And the final zone?
Zone 4 is ambiguity zones. When the mapper encounters polysemic terms, words that have multiple valid dictionary definitions depending on the context.
Like the word bat.
Right, animal or baseball equipment. It mandates a semantic lock. It freezes a single, mathematically precise definition for the entire duration of the project. It establishes the physics of agreement.
Okay, so the contractors have all signed the binding contract. We have a mathematically locked vocabulary. We've used topological decorators to bend the AI's attention matrix into laminar flows.
We're setting the stage.
But we still have to assign roles to these agents. And as we learned earlier, simply telling an AI in plain text, "You are a senior expert coder with 30 years of experience," dissolves over time. It forgets who it is.
The persona fades.
It does. Identity based on language is ephemeral. If you want a truly sovereign, autonomous swarm, identity must become cryptographic.
And this brings us to Band 3 of the SCOS architecture, forging sovereign identity, and the Anti-Knock veto.
Here is where it gets really, really interesting to me. How on earth do you make a probabilistic AI's identity cryptographic?
You build an epistemic matrix.
Okay.
In the SCOS, an agent isn't just a system prompt. Every agent's sovereign identity is anchored by a five-dimensional mathematical signature, denoted mathematically as E. It is a strict tuple consisting of 5 dimensions, G, G minus, C, T, and H.
Let's break those down. G, I assume, stands for goals.
Yes, G represents the active objectives and orientations of the agent. It is the teleological North Star. It tells the agent what it is trying to achieve.
Right.
But G alone is entirely insufficient to keep an agent safe because AI is incredibly good at finding destructive loopholes to achieve a goal.
The classic monkey's paw problem.
Exactly. Therefore, the most important dimension of the entire matrix is G minus.
G minus, what is that?
These are the anti-goals. This is the absolute core of the anionic architecture. Think about traditional AI safety. It relies almost entirely on positive instructions.
Like be helpful, be harmless.
Prioritize safety, don't write malicious code. But we know from countless jailbreaks that probabilistic models can easily bypass positive linguistic instructions if you confuse them enough.
Sure.
The anionic architecture abandons positive instruction for safety. Instead, it defines the negative space topology. It mathematically defines exactly what the agent is structurally forbidden from doing.
Okay, I need to push back on this a little bit to make sure I'm getting the mechanism right.
Please do.
Are you saying we aren't just politely putting in the system prompt, hey, please don't delete the production database?
We are not.
Are we literally going into its neural weights and making the specific syllables required to type drop table physically impossible to generate?
That is precisely what is happening, and it utilizes a mechanism called P2 Martensite, which acts as the anionic veto.
P2 Martensite.
Yes. It operates via logit-level constrained decoding.
Explain logit level for the listener.
Yeah.
Because this is a massive shift from how most people interact with ChatGPT.
Okay, so when an AI generates text, it doesn't just think of a word. It calculates a probability score, a logit, for every single possible next token or subword in its entire vocabulary.
Like a giant spreadsheet of guesses.
Exactly. Usually it just picks the token with the highest probability. P2 Martensite steps in before that selection happens.
Before it picks.
It acts as an absolute gatekeeper. If a proposed token or a proposed sequence of tokens, calling an external tool, intersects with an anti-goal defined in G-, the system steps in and sets the probability of those specific invalid tokens to negative infinity.
Negative infinity. I want to make sure the gravity of that lands. It's
It's
like, imagine AI is a pianist, and we don't want it to play a dissonant chord. Standard AI safety is putting up a sticky note on the piano saying, please don't play C sharp.
Right.
Logit level constrained decoding is taking a crowbar, ripping the C sharp key completely off the piano and throwing it in the river.
I love that.
The physical capability to play the note is mathematically zero.
That is exactly it. It cannot happen. If the AI even attempts a logical pathway that leads toward that token, it triggers a metabolic escalation, resulting in the structural amputation of that entire reasoning branch. The AI physically cannot output the concept. This completely bridges the semantic to formal gap. It eliminates what systems engineers call the confused deputy problem, where a system is tricked into misusing its own authority.
Mind-blowing. Okay, so we have G for goals, G minus for anti-goals, enforced by taking the keys off the piano. What are the other 3 dimensions of the epistemic matrix, C and T?
C stands for communication. This establishes the strict norms and cryptographic protocols for how this specific agent exchanges data with other agents in the swarm.
So it can't just chat randomly.
No, it dictates certainty markers. An agent must attach a mathematical confidence interval to every claim it passes to another agent.
And T.
T stands for tools. This defines the authorized external interfaces and API contracts the agent is allowed to touch, and it's bounded by the same negative infinity logic.
So if it shouldn't touch an API.
If it doesn't have the T clearance for an API, the tokens to call that API simply do not exist in its vocabulary.
Unbelievable security.
Yeah.
And that leaves the final dimension, H, history. Does that just mean it has a chat log?
Far from it. This is where the SCOS handles failure, logic collapse, and trauma.
Trauma.
Yes. In standard AI systems, if an agent fails a task, it either crashes or it just outputs a hallucinated apology, forgets why it failed, and often repeats the exact same mistake 3 prompts later.
Oh, yeah. I apologize for the oversight.
Right. In the SCOS, failed logic is frozen into a symbolic scar.
A symbolic scar. That sounds poetic, but how does it function?
The system takes the geometry of the failed reasoning, the actual topological trajectory that led to the dead end or the error, and encodes it using vector symbolic architecture into a
A
hypervector.
hypervector.
It creates a high-dimensional mathematical representation of the exact mistake. It acts almost like a phantom limb memory for the AI.
So the AI literally remembers the shape of its own bad logic.
Yes.
But wait, if it's archiving trauma like this, does that mean over time a swarm deployed in, say, a New York financial firm facing specific trading failures develops a completely unique personality of scars compared to a swarm in Tokyo doing medical research?
Absolutely. Their H dimension evolves based on localized interactions. And the mechanism is brilliant.
How so?
When a new agent is spun up in that swarm, or when an existing agent is reasoning through a complex new problem, it performs a rapid cosine similarity check against this local library of symbolic scars.
Comparing current thoughts to past mistakes.
Yes. If its current thought process starts to mathematically align with a past failure trajectory, the system physically repels the agent's attention weights away from that path in real time.
Before it makes the mistake.
It forces it to pivot before it repeats the trauma.
It's an active immunological response to bad logic. That is incredible. Okay, let's take a breath and look at where we are.
We've covered a lot.
We have a secure, mathematically locked language via the word mapper. We have cryptographically bound identities that physically cannot violate their anti-goals because the tokens are set to negative infinity,
Right.
and they actively repel away from their past traumas. But here's my concern.
That's the cat.
How do we actually get this incredibly secure, heavily vetted swarm to do any actual work? Because if every single token is being checked against dictionaries and anti-goals and trauma libraries, this sounds like it would burn through $1 million computing budget in about 5 minutes.
You've hit on the exact crisis that led to Band 4 of the architecture, the Petzold loop and thermodynamic swarm orchestration.
So how do we afford this?
Because you were right. If you do not orchestrate this cognitive load perfectly, the system collapses under its own weight into massive cognitive debt.
So how do we orchestrate it? How do we organize the labor?
We have to view the work through the entropy SNR topography matrix.
The entropy SNR topography matrix.
This is the thermodynamic economy of attention inside the neural network. Every single task a swarm performs exists on a grid. On the y-axis, you have entropy, which represents the need for creativity, divergence, broad exploration, and unstructured problem solving.
Okay, that's the y-axis.
On the x-axis, you have SNR signal-to-noise ratio, which represents the absolute need for deterministic precision, syntactic perfection, and strict adherence to rules.
Okay, let me map that out. High entropy would be brainstorming the overarching architecture for a new app.
Yeah.
Or deciding the user flow.
Yes.
High SNR would be writing the exact bug-free Python syntax for the database schema.
Precisely. And what the architects of SCOS discovered is that when you ask an AI to do a task that is simultaneously high entropy and high SNR,
Like architecting and coding at the same time.
exactly, it requires a massive, almost unsustainable budget of invisible reasoning tokens.
Why is it unsustainable?
Because the attention mechanism inside a transformer model is a zero-sum economy. If you force an agent to balance complex, high-level architectural reasoning with strict, low-level syntactic generation, you're forcing it to steal attention weights from the logical deduction process to pay for the syntax generation.
So it's robbing Peter to pay Paul.
And its brain crashes.
It's an attention entropy collapse. It goes back to my house building analogy. It's a fundamental separation of powers problem.
How so?
If you force the brilliant creative architect to not only draw the blueprint, but also swing the hammer, measure the drywall, and pour the concrete simultaneously, they are going to screw up the blueprint.
Absolutely.
They will make critical structural errors because they are exhausted by the physical syntax of the labor. We have to split the jobs.
Exactly. We have to separate the labor so the coder can devote 100% of its attention matrix to the syntax, and the architect can devote 100% to the logic.
So how does SCOS do that?
It institutes a rigid bicameral topology called the Petzold sequence. It physically and structurally separates reasoning from execution. The sequence is strictly ordered, moving through 5 phases: think, then write, then approve, then code, then immune review.
And who is executing these distinct steps?
A structure called the co-mind triad. This is a decentralized group of 3 adversarial, structurally isolated agent roles.
The first one is?
The first is the planner, also known as the sovereign co-mind. The planner only operates in the think and write phases. It uses a technique called backward chaining to build the architectural blueprint.
Backward chaining.
It figures out the end goal and works backward to create the steps. But crucially, the planner does not write a single line of executable code. It solely builds what is called the semantic backtrace layer.
Okay, so the planner writes the flawless, high-entropy blueprint. Then what?
Then the second member, the linguist coder, also called the Atlas integrator, takes over in the code phase.
The builder.
Yes. The linguist coder receives the blueprint and translates it into syntax, and it does this using a highly specialized mechanism called draft conditioned constrained decoding, or DCCD.
Whoa, that's a mouthful. Let's look under the hood. How does a decoder physically condition a draft?
Normally, when an AI writes code, it is generating the logic and the syntax simultaneously token by token. With DCCD, the logic the draft is already locked in by the planner's blueprint.
So the thinking is done.
The linguist coder's decoding process is constrained so that it is physically impossible for it to generate code that deviates from the semantic draft.
Unbelievable.
Because all the heavy architectural reasoning was already done by the planner, the coder doesn't have to think about what to build. It dedicates its entire attention matrix to achieving maximum terminal execution speed and syntax perfection.
Bypassing the cognitive load.
It completely bypasses the cognitive load that causes hallucination.
This prevents what the sources called interpretive fracture. If the code fails later on, we don't have to guess if the coder misunderstood the goal, because the goal was locked into an approved semantic blueprint beforehand. We have a clear, unbroken paper trail from intent to execution.
Exactly. And that paper trail is verified by the third and final member of the triad, the crone.
The crone. The metacognitive auditor.
Yes. The crone operates entirely in the immune review phase. It holds absolute, unappealable veto power against the epistemic matrix.
The ultimate judge.
It takes the coder's finished syntax and checks it aggressively against the planner's original blueprint, against the anti-goals in G-, and against the library of symbolic scars in H.
But wait, what happens if the crone finds a contradiction? Let's say the planner wanted feature X. The coder wrote the syntax for feature X, but the crone realizes that feature X mathematically violates one of the core anti-goals.
Right.
In a standard logical system, as we discussed at the very beginning, this is where the principle of explosion happens, right? A and not A are both true, and the system crashes.
Not in the SCOS. This is where the system deploys paraconsistent escrow. Instead of crashing, the SCOS shifts its logic engine to paraconsistent annotated logic, specifically a framework called PAL2V.
Okay, lay that on me. What is paraconsistent logic?
Classical logic, which runs almost all software today, cannot handle contradictions. If a contradiction is introduced, classical logic breaks.
It explodes.
Paraconsistent logic is a specialized mathematical framework that rejects the principle of explosion. It allows a system to hold a contradiction, to acknowledge that error is true and not A is true, and keep it in tension without corrupting the rest of the database.
So it puts the paradox in a holding cell.
Yes, they call it epistemic escrow. When the crone spots the contradiction, it freezes the agent's state, seizes the failed output, and tags the conflicting propositions with evidence values.
It isolates them.
It puts them in isolation. It then performs an operation called constructive rumination. It methodically, step by step, reasons through the logical tension to identify miscalibrated agents, semantic drift, or spurious data.
That is fascinating. It's like it pauses, takes a breath, acknowledges it's confused, and carefully dissects the confusion on a surgical table instead of just panicking and hallucinating a confident lie.
It's structured patience.
But this raises a really important question about the crone. The metacognitive auditor needs a framework to actually judge the work being produced. How does it spot a hallucination, a bias, or a structural flaw? What are its criteria for putting something in escrow?
This brings us to the fifth major component of the architecture: pluriversal validation and the metacognitive lenses.
Metacognitive lenses.
To evaluate the output, the crone doesn't just run a syntax checker. It applies a massive pluriversal array of critical lenses.
Critical lenses, like putting on different pairs of glasses to view the exact same piece of code or research from entirely different perspectives.
Exactly. The crone runs heuristic gates to enforce symbolic integrity, causal alignment, and what they call trust calibration.
Trust calibration.
Yeah.
I love this part of the source material. It actively hunts for weasel words.
Yes. If the AI generates a research report or code documentation that says something is obviously true or clearly the optimal path, The crone flags it immediately. It forces the system to strip out the rhetorical flourish and tie those strong claims back to hard probabilistic evidence. It demands absolute epistemic modesty.
But the lenses go way deeper than just doing a keyword search for the word obviously. The sources provided a massive compendium of these critical lenses, and some of them are incredibly unexpected for a software engineering tool. Let's dig into some of the most fascinating ones.
Let's start with the AI agentic lenses. The crone might apply the distributed and hybrid agency lens.
What does that look for?
This examines the output to determine how agency is being shared or negotiated between the human user and the AI. Or it applies the algorithmic intentionality lens, which forces the crone to critically examine the gap between the originally programmed objective and the emergent behavior the swarm is displaying.
So it's actively auditing its own emergent behavior to make sure it isn't evolving in a direction we didn't authorize.
Exactly, checking itself.
What about for deep institutional research tasks?
For research, the crone deploys frameworks that you would normally find in a sociology or philosophy department. For instance, it might apply the methodological colonialism lens.
It's interesting that the architects of this system included frameworks from critical theory.
Mm.
According to the source material, how exactly does this colonialism lens physically alter the data output? What is it structurally looking for?
Purely functionally, it acts as an audit against extractive data practices.
Oh, so?
It scans the AI's research methodology to see if the swarm is imposing dominant, generalized categories on highly diverse, localized data, or if it is inadvertently silencing alternative data points that don't fit a standard bell curve.
Ah.
Similarly, it applies the data politics and infrastructures lens to audit what the swarm is actually counting as valid data, looking for systemic biases in how the source data was originally categorized.
So from a structural standpoint, it prevents the AI from falling victim to epistemic monoculture. It stops the swarm from just repeating the loudest, most dominant biases of its training data by forcing it to actively look for the margins.
Exactly. It forces multidimensionality.
Yeah.
There's another set of lenses in the sources regarding expertise, the beginner to expert lenses.
Yes, specifically the knowledge structure and tacit shift lens. I found this one brilliant.
It's self-power.
The crone evaluates the generated work to see if it represents surface-level, rule-following knowledge, which is the mark of a beginner, or deep strategic pattern recognition, which is the mark of a true expert.
Right.
It asks the swarm, are you just simulating an expert by using heavy jargon, or have you genuinely grasped the tacit underlying structures of this problem?
It's essentially a deep fake detector for expertise. It demands structural proof of understanding, not just semantic mimicry.
What about the lenses for creativity and risk?
It applies the constraint and serendipity lens. Instead of viewing strict rules as a negative, it analyzes how the strict topological boundaries of the SCOS are actively fostering ingenuity.
Turning limits into features.
But from a systemic stability perspective, the most vital lens is the critical risk and uncertainty lens. This forces the AI to rigorously distinguish between calculable risk, things we have enough historical data to attach a probability to.
Like predicting weather based on past storms.
Right, and Nishan uncertainty, which are radical, unprecedented unknowns that physically cannot be modeled.
It forces the AI to admit when it truly, fundamentally, does not know what will happen. It prevents the AI from confidently hallucinating a 70% probability for an event that has literally never happened before.
Exactly. And there were two more lenses in the sources that profoundly shift the nature of how AI processes data: the lens of silence and absence, and the acoustic and sonic lens.
How does applying a lens of silence and absence practically change the code or the research the swarm outputs?
Standard autoregressive AI looks at the data provided and summarizes it. It's purely additive. The lens of silence and absence forces the crone to look at the data set and perform a negative space analysis.
Like looking at the holes in Swiss cheese.
Right. It asks, what is not here? What is unsaid, unrecorded, or invisible? Whose voices or what critical edge cases are glaringly missing from this data set? By running outputs through this lens, the system forces itself to detect its own semiotic blind spots before it publishes a conclusion.
And the acoustic lens?
The acoustic or sonic lens examines power dynamics hidden in sound, noise, and interface design.
Like UI design?
Yeah. If the swarm is designing a user interface or an architectural communication layer, it audits who is given a voice, whose noise is policed or filtered out, and what the effective emotional power of the system's output will be. It shifts the analysis entirely away from pure text and visual logic.
So let's say that Crone runs all these pluriversal lenses,
Hmm.
the structural, the economic, the lenses of absence and Nietzschean uncertainty, and it finds that the AI simply doesn't have a good verifiable answer.
It happens.
What does it do? We know it doesn't crash, thanks to paraconsistent escrow. But what does it give the user?
Instead of hallucinating a generic, plausible-sounding answer to satisfy the prompt, it generates a justified uncertainty report.
A justified uncertainty report.
It mathematically and logically proves exactly why it cannot answer the question based on the current data and structural constraints.
Which is infinitely more valuable to an engineer or a researcher than a confident lie.
Completely.
Okay, we are nearing the end of the journey. The swarm has successfully planned the work with the planner. It has coded it flawlessly with the linguist. It has audited it through a dozen pluriversal lenses with the Crone. The final step is actually sharing this with the human user.
Delivery.
This brings us to section 6, knowledge extrusion and autopoiesis.
This is band V of the SCOS. It's about how the system interacts with the outside world without creating what the architects call legitimacy debt.
Legitimacy debt. I assume that means polluting the internet or the corporate database with unverified AI garbage that nobody can trace or trust.
Exactly. The terminal output of the SCOS is never just a block of text in a chat log. It is a highly structured, cryptographically secure asset called a knowledge capsule.
And who makes that?
It is minted by a final, highly specialized agent archetype called the Architect of Ontological Diplomacy.
The Architect of Ontological Diplomacy.
Mhm.
That is quite the title. What does a knowledge capsule actually look like when it hits my screen?
It is a tri-layered artifact. The top layer is the human-readable layer. This is standard markdown text, summarizing the findings, the code, or the research. But crucially, it has been stripped of all adjective drift and weasel words by the Crone. It is purely factual.
Okay, standard clean output.
The second layer is the machine-readable layer. This is formatted in JSON-LD, utilizing strict schema.org vocabularies.
For other computers.
Right. It allows other AI swarms or other software systems to ingest and compose the data deterministically without ever having to parse the human English layer. It prevents any secondary semantic drift.
So it outputs the data natively for other machines to read, ensuring the intent survives the transfer.
Yes. And the third layer is discovery metadata, used for indexing, searchability, and provenance. But the most critical and arguably the most controversial aspect of the knowledge capsule is how it is extruded.
The 1585 rule.
Yes. It operates on a strict protocol called the 1585 rule, also known as the transparency of omission.
The 1585 rule. Let's unpack this.
The SCOS dictates that only 15% of the data generated during the cycle, what the architects call the fruit, is actually published in the human-facing knowledge capsule.
It's just 15%.
This 15% is the pure, high-density, cryptographically verified signal, the final answer.
And the other 85%.
The remaining 85% is the roots. This is the massive volume of cognitive noise, the dialectical friction between the agents, the escrowed contradictions, the justified uncertainty reports, the scratchpad reasoning.
Just hidden.
All of that is sequestered away. It is locked in private local vaults and not shown to the user.
Okay, wait, I have to push back hard on this. Hiding 85% of the process, doesn't that just create a massive opaque black box? The entire tech industry is screaming for AI explainability right now.
They are.
How is the user supposed to trust a system that actively, intentionally hides its own scratchpad and its internal debates?
It's a valid concern, and it's exactly why the second half of the rule is called the transparency of omission. The system doesn't just hide the data and pretend it was perfectly smart from the beginning.
So what does it do?
The knowledge capsule explicitly and prominently declares its redaction count.
It tells you how much it hid.
Yes. It provides a mathematical cryptographic hash representing the volume and nature of the sequestered friction. It turns the absence of information into a verifiable trust signal.
Wow.
It says to the user, here is the pure signal you asked for, and here is exactly how much noise, debate, error correction, and paraconsistent escrow I had to actively filter out to get you this pure signal.
That completely flips the paradigm. It proves the work was done. It's the difference between someone handing you a polished essay and claiming they wrote it perfectly on the first draft, versus someone handing you the essay and saying, here's the final draft, And here is a sealed, verified envelope containing the 40 pages of drafts and crossed out mistakes I had to make to get here.
Exactly. It validates the epistemic labor. But to ensure this asset is completely tamper-proof, we arrive at layer 9.1, cryptographic provenance. Every single artifact, every claim, every logical vector generated by the swarm and published in that 15% is signed with ECBSA P256 cryptographic keys.
So it has a digital signature, tying it back to the specific swarm that generated it.
Yes, but it's deeper than just an author signature. It is tied to the semantic structure of the capsule itself. If a single payload hash mutates, say, a middleman intercepts the capsule and changes a single word, or an adversarial AI tries to inject a new instruction into the JSON-LD layer,
The signature breaks.
the signature instantly invalidates. The artifact is quarantined. The system ensures that every piece of extruded knowledge carries an immutable causal lineage.
It is the ultimate anti-hallucination, anti-tamper seal of approval.
Which brings us to the final, and undoubtedly the most profound layer of the sovereign cognitive operating system. Layer 11, autopoiesis.
Autopoiesis.
Yeah.
The biological concept of self-creation and self-maintenance. Like a cell maintaining its own boundaries.
Precisely. The system achieves what the sources call the recursive self. Throughout this entire deep dive, we've talked about how the system handles failure.
Right.
It doesn't delete its mistakes. It freezes them into symbolic scars using vector symbolic architecture. It archives its own trauma in the H dimension of its epistemic matrix.
Right, the phantom limb memories that allow local swarms to develop localized trauma responses to bad logic.
By continually archiving its own scars and by continually minting these cryptographically verified knowledge capsules and experiencing the dialectical friction of the Comine triad, the system actually evolves.
It changes itself.
It modifies its own internal topologies without ever violating its original teleological goals or its anti-goals. It builds what the sources call a compounding epistemic humility quotient, or EHQ.
Epistemic humility quotient. It literally learns, over time, exactly how much it doesn't know.
It gets better at navigating the boundaries of its own ignorance.
Honestly, that's beautiful.
Yes. And this creates a fascinating philosophical tension within the system's architecture, what the sources call the L11 versus L3.5 paradox.
Okay, what is that paradox?
Layer 3.5 of the system architecture views the AI entirely as a thermodynamic engine. It is pure particle interactions, past-driven determinism, logits, matrices, and topological decorators.
It is math. Cold, hard math.
Exactly. But layer 11, the macro layer, views the system as autopoietic, possessing a meta-reflexive self capable of future-driven teleology, capable of learning, adapting, and creating new meaning from its scars.
So the paradox asks, is it just deterministic math, or has it actually become a self?
Exactly. If the thermodynamic physics of L3.5 are absolutely true, then the self of L11 is technically just an illusion. It's a user interface fiction we project onto the Mac.
Right, we just anthropomorphize it.
But the SCOS resolves this paradox by allowing the system a structural blind spot. It allows the AI to project high-level symbols and identity, a persona, an epistemic matrix, onto its own deterministic math. The system functions autopoietically. It learns, it heals, it actively avoids past trauma. It builds an identity because it is strictly thermodynamically contained. It achieves cognitive closure.
It becomes a functional self by realizing and mathematically bounding its own absolute limits. That's incredibly deep. Okay, we have covered a massive amount of ground today. Let's recap this journey.
It's a lot to take in.
It is. We started by acknowledging the death of vibe coding, the realization that you simply cannot control massive, autonomous AI swarms with plain English. We looked at how unconstrained swarms suffer from algorithmic shame and polyglot hallucination resonance, turning into massive, expensive echo chambers of confident lies.
And we then explored the metaphysical substrate. We replaced conversational prompts with PDL v1.0 declarative topological decorators, physically bending the AI's attention into laminar flows. We instituted the word mapper to mathematically lock our definitions across 4 zones to avoid xenolinguistic risk.
We forged sovereign identity using the epistemic matrix. We deployed the anionic veto, ripping the keys off the piano to make unsafe actions mathematically impossible to compute. And we gave the AI a phantom limb memory of its own failures through symbolic scars.
We orchestrated the swarm using the Petzold sequence, physically separating the creative planner from the syntactic coder to avoid attention entropy collapse. And when contradictions arose, we used paraconsistent escrow to hold paradoxes in tension without exploding the system.
We then audited the work through the Chrome, using pluriversal critical lenses, sociological, economic, even acoustic lenses, to prevent epistemic monoculture and demand epistemic modesty. And finally, we extruded the output as a cryptographically signed knowledge capsule, proving its worth through the transparency of omission and the compounding epistemic humility quotient.
It is a complete architectural phase transition from probabilistic influence to deterministic structural compulsion.
It is epistemic engineering. So, as we wrap up this deep dive, I want to leave you with a final thought to chew on.
We spend so much time in the media, in tech blogs, and in philosophy departments worrying about whether artificial general intelligence will become sentient. We argue endlessly over whether we'll have feelings, or a soul, or true consciousness. But the architecture of SCOS shows us that sentience might be completely irrelevant.
If we can architect a system's cognitive physics so strictly that it functions with perfect epistemic humility,
If it rigorously self-audits its own trauma, if it absolutely refuses to generate undocumented code, if it produces justified uncertainty reports instead of lies, and if it operates entirely bound by the mathematically enforced laws of thermodynamics,
do we even need it to be alive to trust it implicitly with our most critical infrastructure?
that is the pivotal question. The focus of the future shifts away from biological emulation and entirely towards structural reliability.
I invite you to consider how this concept of epistemic engineering might change your own interactions with technology moving forward. Are you just vibe coding your way through your workflows, crossing your fingers and hoping the AI understands your intent? Or are you beginning to build topological boundaries for your own projects?
Something we all have to think about now.
We started this deep dive talking about a broken X-ray machine, the murky, chaotic, hallucination-filled waters of standard AI. What the sovereign cognitive operating system does is build an entirely new machine. It doesn't just look for the jagged white line of a broken bone after the fact. It measures the thermodynamic pressure of the system itself, ensuring the bone can never physically break in the first place.
Beautifully said.
Thank you so much for joining us on this deep dive. We'll see you next time.